Hi, good morning everyone. My name is Joylee Caboquing, currently studying BS Computer Science in Biliran State University. And my task today is to show you how to minimize a DFA. So, I have here the example of DFA in which I have 5 states, A, B, C, D, E. And our task is to minimize this DFA. The first step is to draw a transition table for this DFA. You have 0 equivalent and 1 equivalent. You have A, B, C, D, E. And by the way, this is the non-final state, the single circle, C, A, B, D, and we have the double circle is the final state. Okay, so let's proceed to our transition table. We have AB. So I have drawn here the transition table wherein we have 5 states, the A, B, C, D, E, and A is the starting state or the initial state and E is the final state. And given input 0 and 1, these where these states go. So let's proceed now to the minimization of DFA, wherein we have to start with the 0 equivalent. Okay. 0 equivalence. 0 equivalence. So in order to write down the 0 equivalence, you have just to write the non-final state together as one set and the final state as another set. So here are my non-final state A, B, C, D, and I will make this as one set. A, B, C, D. And my final state, I have only one final state, so that is E. And this is the first step of writing the 0 equivalence. So now, let's proceed to the 1 equivalence. 1 equivalence. In order to write down the 1 equivalence, you have to look at for the set of 0 equivalence. And then, you have to compare A to B, A to C, A to D. If this set falls into this one set. So let's start with the A and B. So now, let's check the A and B here in the transition table if this state fall into the same set. Okay, A and B given inputs 0 and 1 where this state goes. A given input 0, it goes to B, and B given input 0, it goes to B. Then the process is not done yet. We have to check for the input 1. Okay, A given input 1, it goes to C, and B given input 1, it goes to D. So let's check here if the C and D is in the same set. Okay, so C and D, it is in the same set. So because C and D falls into the same set, I will make A and B. I will write down A and B into together in one set. So now let us check the A and C here in the transition table if they falls into the same set. So A getting input 0, it goes to B, and C getting input 0, it goes also to B. So they falls into the same state, but the process is not done yet. So we have to check the 1 equivalence. Okay, A given input 1, it goes to C, and C given input 1, it goes to C. So C, because they are the same, so we don't have to worry. C is also falls into the same set, C. And now let us also, so we are done here. So let's check the D. So let's see if D falls into the same set also. A given input 0, it goes to B, and D given input 0, it goes to D. And they are the same state. But we have to check for 1, A given input 1, it goes to C, and D given input 1, it goes to E. So let's check if C and E is falls into the same set. Okay. C and E. So C is here and E is here. So they are another set. Okay. E here, C here. So I have to close this set and make another set for the D. And then bring down the E as it is. So now, let's proceed to the two equivalents. Two equivalents. And in order to write down the two equivalents, let's check for this row. The A, B, C. Okay, let's compare this again, and then D and E, we don't have to compare. We don't have to compare them because they are separate. Let's check for the A and B first. So let's check now for A and B here in the transition table. A given input 0, it goes to B, and B given input 0, it goes to B. So we have no problem with that because it falls into the same set, the same state. So A given input 1, it goes to C, and B given input 1, it goes to D. So let's check if C and D falls into the same set. So C is here, D is here. So they are in the separate set. So I will make A as one set and make another set for B. And now I will check the next A to C. A to C. A given input 0, it goes to B, and C given input 0, it goes to B. They are the same state. So A given input 1, it goes to C, and C given input 1, it goes to C. So it is the same. So we have to check if we don't have to check now. It is as is that A and C falls into the same set. And then I will close the set and bring down D and E as it is. So we are done now with the two equivalents. Let's now proceed to three equivalents. Three equivalents. Okay. For three equivalents, we have to check in this row of two equivalents if A and C falls into the same set again. So let's check E and C here in the transition table. A given input 0, it goes to B. Then C given input 0, it goes to B, no problem. So E given input 1, it goes to C. C given input 1, it goes to C, no problem, they are the same. So I will put A and C into the same set again, and we don't have to check for B, D, E because they are already in the separate set. So I don't have to combine them with anything. So I will bring B down and copy the D and then copy the E. As you can observe, guys, two equivalents and three equivalents are the same. Look, A, C as one set, B, D, E. A, C as one set, B, D, E. So that means we have to stop the process. So we can now draw the DFA. And as you can see, we have 1, 2, 3, 4, 5 state here, and I already minimized it with 4 because A, C as one set, B as one set, D as one set, E as one set, 1, 2, 3, 4. So they are only 4. We can now draw our DFA. So I will base here as one set. Let's write here A, C as non-final state, and then I have B, this one non-final state, and D and E. E is the final state, right? So A is the starting state here, or the non-final state. I will put here this. So the next process for our DFA, let's base here. So A and C as non-final state. Let's locate here A and C. A given input 0, it goes to B, and C given input 0, it goes to B. So we have to put here AC goes to B given 0, and then A and C given input 1. A given input 1, it goes to C, and C given input 1, it goes to C. So as you can see, C and A is in the same set, and then let us just put back here because C is here. Let's put 1 here, and now let's proceed to B. B given input 0, it goes to B. It goes to B. So let's put here 0. Then B given input 1, it goes to D. So it goes to D. Let's put here 1. So now let's proceed to D. Let's proceed to D because C is not a problem now because it is completed. So D given input 0, it goes to B. D given input 1, it goes to D given input 0, it goes to B. So let's put here 0. Put 0 here, and then D given input 1, it goes to E. So let's put here 1. Okay, so now let's proceed to E, the final state. Like E given input 0, it goes to B. So given input 0, it goes to B. And then E given input 1, it goes to C. Let's put 1. So we are now done with the process. This is now the minimized version of our DFA. Look, 1, 2, 3, 4, 5. We have 5 state here, but in here we have minimized only 4. 1, 2, 3, 4. And that's all for the process of minimization of DFA. I hope you learned from this video, guys. And thank you for watching, everyone. Again, my name is Joylee from Caboquing from BSCS 2B.